Hello friends, myself Nandakumar Rauvale from College of Engineering Ambajogay is going to deal with fluid mechanics. So in previous class we have discussed some of the numericals on Buckingham's pi theorem. Today also we will discuss some of the numericals on Buckingham's pi theorem method. So now we will discuss this problem where the frictional torque T of a disk of diameter d rotating at speed n in a fluid of viscosity mu and density rho in a turbulent flow is given by, so correlation is given in this case. So we have to correlate this torque with rest of the four parameters, that is diameter, speed n, viscosity mu and density rho. So now when we want to derive this equation, at that time one thing we can observe from this equation, if we transfer this term on left hand side, this equation becomes T divided by d to the power of 5 n to the power of 2 rho is equal to phi of mu divided by d square n rho. So now we see in these two terms, this is first term and this second term. So what is common is dn rho is common, dn rho is common. Here t is different and mu is different. So that means dn rho has to be taken as the repeating variable. So this is the indication from this equation. If there are this is pi 1 term and this is pi 2 term. So in pi 1, pi 2 term or pi 3 term, the terms which are shown here as common terms, so those common terms indicate that we must take these terms as a repeating variable, then only we can get this equation as a result. This is very important thing that you must remember, that in case if such direct derivation or direct answer is given, at that time which parameters, which variables have to be taken as the repeating variable. So you will sort out the pi terms. So this is pi 1 term, this is pi 2 term, pi 3 term and so on. So and all these pi terms, you find three dimensions or three variables repeatedly, and those variables indicate that these variables you have to take as a repeating variable. If you take some other variable as a repeating variable, then it becomes difficult for you to get the result in this way. So therefore here it is concluded that repeating variables must be dn rho. Now we see how to simplify this. So new term given here is rpm, speed, revolutions per minute. So velocity, angular acceleration, angular velocity. Okay, angular velocity has got dimension t to the power of -1. So this is to be remembered. Either it may be n or omega. So now first we will see the terms which are given here. First term is T or torque. So for torque, dimension given is torque is ml square t to the power of -2, ml square t to the power of -2, m l square t to the power of -2. This is new term. Then we have diameter d, which has dimension l. Then we have speed, angular speed, that is rpm. So which has got dimension t to the power of -1. Then viscosity mu has got dimension m, L to the power of -1, t to the power of -1. Then density rho has got dimension m, L to the power of -3. So we have 1, 2, 3, 4, 5 variables. Number of variables is equal to 5. Number of fundamental dimensions is equal to 3. Therefore, n minus m means 5 minus 3, 5 minus 3, which is equal to 2 pi terms we get. So now here we must see, that is the function torque t is depending on function f of diameter, speed, viscosity and density, or this can be written as some other function f1 is function of torque, diameter, speed, viscosity and density, which is equal to 0. So now we can find two pi terms, or this also can be written as pi1 is function of, that is psi of pi2, or we can write this as psi1 is function of pi1 comma pi2 is equal to 0. This can be written in this way. So now if we get pi1 and pi2, generally we use this correlation in this Buckingham's pi theorem method. This first pi term is equal to function of rest of the pi terms. So pi1 is equal to function psi of pi2, pi3, pi4 and so on. Here we have only two pi terms. So now pi1 term is equal to, so first of all we will see the repeating variables. First of all, the variable which is having geometrical property. So which is having geometrical property is diameter, d. Then second one is flow property. So which term is having flow property is speed, that is n. Then third one is fluid property. Fluid property is having for density rho. So already we have decided which terms have to be taken as repeating variable. So in this case we have decided d and rho must be the repeating variables, and accordingly we have chosen here. So here in place of rho, mu can also be chosen, but we have not selected this mu because as per the question a repeating variable must be a rho. So therefore we have selected d, n and rho as the repeating variables. So now we see here this pi1 term can be written as d to the power of a1, n to the power of b1, rho to the power of c1 and torque t. So this is first term where we are going to include this dependent variable. Then pi2 is equal to d to the power of a2, n to the power of b2, rho to the power of c2, and only one term which is remaining is mu. So we call this as first equation, that is pi1 is equal to phi of pi2. Then we call this as second equation and this as third equation. Now we write pi1 term. Pi1 is equal to d to the power of a1, n to the power of b1, rho to the power of c1 torr t. So dimensions of pi1 is dimensionless, therefore m to the power of 0, l to the power of 0, t to the power of 0, which is equal to d. Dimension for d is l to the power of a1. Dimension for n is t to the power of minus 1 to the power of b1. Then density, dimension for rho is m l to the power of minus 3 c1. Dimension for torr t is m l square t to the power of minus 2. So on simplification, this gets m to the power of 0, l to the power of 0, t to the power of 0 is equal to l to the power of a1, t to the power of minus b1, then m to the power of c1, l to the power of minus 3c1, m to the power of 1, l to the power of 2, t to the power of minus 2. Now collecting powers of m. So on left hand side, power of m is 0 is equal to power of m is c1, power of m is 1 plus of 1. So we get c1 is equal to minus 1. c1 is equal to minus 1. Now collecting powers of t. So we collect first powers of t, that is t to the power of 0 means on left hand side 0 is equal to here t to the power of minus b minus b1, then here minus 2, 0 b1 minus 2, or b1 is equal to minus 2. So this is that b1. Now collecting powers of that is L. So now power of L is 0 on left hand side. This is 0 is equal to, here power is A1, then minus 3C1 and 2 plus 2. So now we know C1, B1. Now we want to find out A1. So A1 is equal to 3C1 plus of 2. So C value is minus 1, minus 3 plus 2 means this will be minus 1. So here we obtain this value as A1 value as A1 is equal to minus 1. So we know value of A1, B1, C1. So we can write here pi1 term. Pi1 term we can write as d to the power of A1, n to the power of B1, or rho to the power of C1 into torr t. So d to the power of a1 means pi1 is equal to a value is minus 1, n to the power of b1, b1 is minus 2, and rho to the power of c1 is minus 1 into torque T. So this can be written as T divided by d n square rho. Pi1 torque is given by dn square rho. So this we call as equation number 4. Now taking pi2 term, pi2 is equal to d to the power of a2 n to the power of b2 rho to the power of c2 mu. So this is equation number 3. Again taking pi2 term. So dimensions of pi is m to the power of 0, l to the power of 0, t to the power of 0. Dimension of this d is l to the power of a2. Dimension of n is t to the power of minus 1 to the power of b2. Dimension of rho is m l to the power of minus 3 c2. Dimension of mu is m l to the power of minus 1 t to the power of minus 1. Now again we write this as m to the power of 0, l to the power of 0, t to the power of 0 is equal to l to the power of a2, t to the power of minus b2, m to the power of c2, l to the power of minus 3c2, m to the power of 1, l to the power of minus 1, t to the power of minus 1. Collecting powers of m. On left hand side power of m is 0 is equal to, on right hand side power of m is c2 and here 1 plus of 1. So c2 is equal to minus 1. Then collecting powers of t we take first. On left hand side power of t is 0. On right hand side power of t is minus b2. And minus 1. So b2 is equal to minus 1. c2 is equal to minus 1, b2 is equal to minus 1. Then collecting powers of L. So power of L on left hand side is 0 is equal to a2 minus 3c2 and minus 1. So a2 is equal to 3c2 plus 1. So c value is minus 1 minus 3 plus 1. So a2 value is going to be minus 2. Okay, so coming to this next slide, A2 value which we obtained is -2, B2 value we obtained is -1, C2 value we obtained is -1. Therefore, pi2 term is d to the power of A2, n to the power of B2, rho to the power of C2 mu. So d to the power of A2 means d to the power of -2, n to the power of -1, rho to the power of -1 mu, or pi2 term is equal to, so these terms are negative, will appear in the denominator, mu divided by d square n rho. So this is pi2 term. We can call this as equation number 5. So now equation number 4 is pi1. Pi1 term is given as t divided by dn square rho, t divided by dn square rho. So this is equation number 4. Equation number 4 and 5 give us different pi terms, that is pi1 and pi2 terms. So as we know, we can write it in two different ways. That is, function phi1 is function of pi1 term and pi2 term, which is equal to 0. According to this, we can write as phi1 is function of t divided by d n square rho, then mu d square n rho is equal to 0, or we can write this as pi1 is function of, according to equation number 1, psi of pi2. We can write here t divided by d n square rho is equal to phi of mu d square n rho, or torque T is equal to d n square rho psi of mu divided by d square n rho. So now we can see this question given. So t d to the power of n square rho mu divided by d square n rho. T d to the power of n square rho, given question is t d to the power of 5 n square rho psi of mu d square n rho, mu divided by d square n rho. So now what we see here is there is 5 in the power of d, so this is given by mistake. This is wrong. Actually it must be 1, as we have simplified without any mistake. So this is a wrong thing which is asked in the derivation itself or in the question itself. So these are the certain mistakes. Yesterday also we have seen one mistake, so that was the printing mistake in question itself. So even if you simplify at your own, you won't get it at as 5. So this is going to be 1 only. Okay, now we'll go to this second. So this is actual answer. and in problem this is by mistake, printing mistake, this 5 is printed. Okay, so this given thing is wrong because of this d to the power of 5. So d to the power of 5 is not there, only d to the power of 1 is there. So now coming to this next problem. The pressure difference delta P in a pipe of diameter D and length L to viscous flow depends on viscosity, velocity V, viscosity mu, and density rho. Using Buckingham's pi theorem, obtain expression for delta P. So here correlation is not given. We have to decide our own the correlation or the final correlation, that whatsoever we get we have to write. So now, so we have to find out the correlation for delta P in terms of diameter, length, velocity, viscosity, and density. So now we take these terms. So very first term is delta P, which is pressure. So this pressure P is going to depend on diameter, length, velocity, viscosity, and density. So we will collect these terms. So very first is delta P. Delta P. So dimension for delta P that we know is pressure dimension is m L to the power of -1 T to the power of -2, change in the pressure. We can see in this pressure, for pressure stress it will be say pressure intensity m L to the power of -1 T to the power of -1. Then second parameter is D, for that is dimension is L. Then length, again dimension is L. Then velocity V, dimension is meters per second, L T to the power of -1. Mu, dimension for mu is ml to the power of -1 T to the power of -1 is here, ml to the power of -1 T to the power of -1, ml to the power of -1 T to the power of -1. Then density rho, kg per meter cube mass, L to the power of -3, L to the power of -3. So these are the 1, 2, 3, 4, 5, 6 variables we have. Number of variables is 6. Number of fundamental dimensions is equal to 3. Therefore, number of pi terms we get is n minus m, which is equal to 6 minus 3. We get 3 pi terms. So now we can write the equation function f1 as the function of delta P D L V mu rho is equal to 0, or delta P is function of d, l, v, mu, rho, or we can write it as psi 1 is function of pi 1, pi 2 and pi 3 term, which is equal to 0, or we can write pi 1 is function of psi of pi 2 and pi 3 terms. So now we can define pi 1 term, pi 2 term and pi 3 term. Pi 1 term is equal to, first of all we must define the repeating variables. So first term, geometrical property, the variable with geometrical property which we select is say diameter. Then flow property, so flow property we select as velocity. Then geometrical property, diameter we may select, or length we may select, it depends. So you may select this either or this. Then velocity, then fluid property, so in fluid property we may select density or viscosity. So here we can select viscosity. So it depends, it is left to us, it is our choice whether to select diameter or length, whether to select viscosity or density. It makes no difference. So now we write pi 1 term. Pi 1 term is equal to d to the power of a1, v to the power of b1, mu to the power of c1, and first pi term contains dependent variable delta p. So in first pi term we must include dependent variable, then we call this as equation. So this equation we call as 1 and this equation we call as 2. Then pi 2 term, d to the power of a2, v to the power of b2, mu to the power of c2. Then we have el, we can take el, this will be third equation. So already d, then v and mu are repeating variables. First we selected delta p, second we selected l, now left is rho. So in pi 3 term, d to the power of a3, v to the power of b3, mu to the power of c3 and rho. So we call this as equation number 4. So we can take these equations one by one. First we take pi 1 term, d to the power of a1, v to the power of b1, mu to the power of c1 delta p. So this is equation number 2 we have selected. Now substitute the dimensions for pi 1 term. Pi 1 is dimensionless, so m to the power of 0, l to the power of 0, t to the power of 0, d means diameter, l to the power of a1, v means velocity, l t to the power of minus 1 to the power of b1, then mu is m, l to the power of minus 1, t to the power of minus 1 to the power of c1, then delta p is m, l to the power of minus 1, t to the power of minus 2. So again we rewrite this as m to the power of 0, l to the power of 0, t to the power of 0, which is equal to l to the power of a1, l to the power of b1, t to the power of minus b1, m to the power of c1, l to the power of minus c1, t to the power of minus c1 m to the power of 1 l to the power of minus 1 t to the power of minus 2. So now we will collecting powers of m. So on left hand side power of m is 0. On right hand side this is m to the power of 0. On right hand side power of m is c1 plus 1. c1 plus 1. c1 is equal to minus 1. So now collecting powers of we collect powers of t. First power of t on left hand side is 0 is equal to power of t is minus b1, then here minus c1 and here minus t2, sorry minus 2, 0 b1 minus b1 minus c1 minus 2, or here b1 is equal to minus c1 minus 2. So c1 value we know, that is minus 1, minus of minus it will become plus, sorry plus 1 minus 2, so this will be minus 1. So b1 is going to be minus 1. Then collecting powers of L. So power of L on left hand side is 0 is equal to, here power of L is a1, then b1, then minus c1, then minus 1, 0 a1 b1 minus c1 minus 1. So we obtained a, b and c, so we are left with a. So a1 is equal to minus b1 plus c1 plus 1. So transferring these terms, b1 c1 and 1 on right hand side will become, change their sign, minus b1 plus c1 plus 1. So b1 value we know minus 1, so minus of minus it becomes plus 1. c1 value we know, that is minus 1, so minus 1 plus of 1, so minus 1 plus 1 gets cancelled, a1 is 1. So a1 value we get as 1. So now pi1 term can be written again as d to the power of a1 v to the power of b1 mu to the power of c1 delta p. So d to the power of a1 means d to the power of 1, v to the power of b1 means minus 1, mu to the power of minus 1 delta p. So we can write it as delta p into d divided by mu v is pi1 term. We get pi1 term as delta p into d divided by mu v is this first pi term. So we call this as equation number 5. Now coming to the pi2 term. So pi2 term is equal to d to the power of a2 v to the power of b2 mu to the power of c2 L. So this is equation number 3. Already we have used 2. Now we are going to use pi2 term d v mu L. d v mu L. So this is pi2 term. So dimension for pi2 is m to the power of 0, l to the power of 0, t to the power of 0. Then dimension for d is l to the power of a2, v is meters per second, l t to the power of minus 1 to the power of b2. Then mu, again dimension for mu is m l to the power of minus 1, t to the power of minus 1 to the power of c2 and l. A to the power of 2, l t to the power of minus 1, b2m l to the power of minus 1, t to the power of minus 1, c2l. Okay. So now again simplifying, m to the power of 0, l to the power of 0, t to the power of 0 is equal to l to the power of a2, l to the power of b2, t to the power of minus b2, then m to the power of c2, l to the power of minus c2, t to the power of minus c2, l. So collecting powers of m, so this is 0 is equal to c2. Only two locations we get m, therefore c2 is equal to 0. Then collecting powers of t to the power of 0, 0 is equal to minus b2 minus c2. So we know c2 value is 0, therefore b2 value is also going to be 0. We have t at two locations, 1, 2, 3, 3 locations. So here minus b2 minus c2. So b2 is also equal to 0. Now collecting powers of we say L. So powers of L, here we have power of L is 0 is equal to A2 B2 A2 plus B2 minus C2 and 1. So A is 0, sorry, C is 0, B is 0, only A. So A2 is equal to minus 1. We get A2 is equal to minus 1. So now this pi2 term is defined as d to the power of a2, v to the power of b2, mu to the power of c2 l. So d to the power of a2 means minus 1, v to the power of b2 is 0, mu to the power of c2 is 0 and l. So here we can write this d in the denominator, whereas this v to the power of 0 and mu to the power of 0 becomes 1. So this pi2 term, pi2 is equal to, we can write as L divided by D. So this is second term, pi2 term we obtain as L divided by D. Now we can get pi3 term. So from equation this 4, we write this pi3 term, that is d to the power of a3, v to the power of b3, mu to the power of c3 rho. So this is equation number 4. Equation number 4 contains rho. So this is equation number 4. Now again writing powers of dimensions of this as m to the power of 0, l to the power of 0, t to the power of 0 is dimension for pi, l to the power of a3, then l t to the power of minus 1 to the power of b3. Dimension for velocity is L t to the power of minus 1. Then dimension for mu is m L to the power of minus 1 t to the power of minus 1 c3. And dimension for rho is L kg per meter cube mass into length to the power of 3. So this is for pi 3 term. Now we can simplify this as m to the power of 0, L to the power of 0, t to the power of 0 is equal to L to the power of a3, L to the power of b3, t to the power of minus b3, m to the power of c3, L to the power of minus c3, t to the power of minus c3, m L to the power of minus 3. So collecting powers of m, we get here 0 is equal to c3 plus 1. So c3 is equal to minus 1. Again collecting powers of t, we say. First we take t to the power of 0 means on left hand side 0, t to the power of minus b3 minus b3 minus c3. So from this we can get b3 is equal to minus c3 or is equal to minus c value is minus 1 minus of minus plus 1. So b3 is equal to plus 1. b3 is equal to plus 1. Then collecting powers of L to the power of 0 is equal to L to the power of a3 plus of b3 minus of c3 then minus 3. a3 is equal to minus b3 plus c3 minus 3. So value of b is 1. So minus 1. Value of c is minus 1. So minus 1. And a3 is equal to minus b3 plus c3 minus of minus, this becomes plus 3. So therefore it becomes 1. a3 is equal to 1. Now we can write pi 3 term. Term pi 3 is equal to d to the power of a3, v to the power of b3, mu to the power of c3 rho. So d to the power of a3 means d to the power of 1, v to the power of b3 means 1, mu to the power of c3 means minus 1 rho. So what we get is d v rho divided by mu. So this is pi 3 term. So we can call this as equation number 4. So now collecting equation number 1 from 1, 2, 3, 4. So sorry. So this is equation number not 4. We had obtained pi 2 term here. Equation for pi 1 is 5. Equation 5. So this is equation number 6. For pi 2 term, this is equation number 7. Equation number 7. So collecting equation 1. Equation number 1 is pi 1 is equal to phi of pi 2 pi 3. pi 1 is equal to phi of pi 2 pi 3. So this is equation number 1. So we collect pi 1 term. Pi 1 term is pi 1 is equal to delta p d divided by mu v. This is equation number 5. Then pi 2 term is L divided by D, equation number 6. L divided by D, equation number 6. Then pi 3 term, just now we obtained as dv rho divided by mu. dv rho divided by mu. This is pi 3 term, equation number 7. So as per equation number 1, we can write it as delta p d divided by mu v is equal to phi of pi 2 term is L divided by D, comma dv rho divided by mu, or this can be written as delta p is equal to mu v divided by D, phi of L divided by D, dv rho divided by mu. So this is the final correlation, or we can write this as the final correlation. Delta p is equal to mu v divided by D Now one thing we can observe, length of pipe and diameter of pipe is not going to vary, so this can be treated as a constant. We can take it outside this. So delta p is equal to mu v divided by D into L divided by D, psi of dv rho divided by mu. So we can take this. So this can be taken as the final derivation. So if you got the idea, if you click this idea that L and D, length and diameter are constant terms, both are constant terms, so then we can take it outside, or it is a linear function of L by D. So we can write this as delta p is equal to mu v L mu v divided by D into L divided by D, psi of rho v D divided by mu, or this rho v D divided by mu is Reynolds number. We can write this as mu v divided by D into L by D, and function of Reynolds number, we can call this as a Reynolds number, where a Reynolds number is equal to rho v D divided by mu. So we can represent in this way also. You can stop here, or you can come up to this stage, or you can write this as so we will stop here. Okay. So this can be the result you can define, or in this itself you can write in place of this as rho vd as a Reynolds number. So here we stop, and I can say that we have seen how to use Buckingham's pi theorem method and release method. So now we will move to the next bit in next lecture. Thank you.